So first we'll do all the formulas of moles. The first formula for number of moles is N equals to mass on MR or AR. Mass is in grams and MR or AR has to be calculated using the masses given in the periodic table. Now the next formula for the volume of a gas, V equals to N into 24 decimeter cube, or V equals to N into 24,000 centimeter cube. If we have to find the volume in decimeter cube, then we use the first formula, and for centimeter cube, we use the second formula. The next formula for the number of particles, which is called the Avogadro constant, is P is equals to N into 6 to 10 into 10 is the power 23. Now over here, N is the number of moles. P stands for the number of ions, atoms, or molecules. For concentration, we have the formula N is equals to C into V over 1000. Now here C is the concentration in mole per decimeter cube. Our volume will be in centimeter cube. If the volume is given in decimeter cube, then we'll use now let's do some questions based on these formulas. Calculate the mass of MgO when 100 gram of MgCO3 reacts. MgCO3 decomposes on heating. For this, we'll first write the balanced chemical equation. The decomposition of a carbonate produces a metal oxide and carbon dioxide gas. We have 100 gram of MgCO3 and we have to find the mass of MgO. So we'll first find the moles of MgCO3, that is 100 upon the mass of magnesium is 24, the mass of carbon is 12, and the mass of oxygen is 16. So the moles of magnesium carbonate will be 1.19. Now the ratio of magnesium carbonate to magnesium oxide is 1:1. So on using 1.19 moles of magnesium carbonate, 1.19 moles of magnesium oxide will be produced. Now we'll use the formula N is equals to mass upon MR. N over here will be 1.19. We have to find the mass, and the MR of magnesium oxide is 24 plus 16. So the mass will be equals to 47.6 grams. The next question is calculate the volume of carbon dioxide produced when 100 grams of magnesium carbonate reacts with H2SO4. For this again, we'll first write the balanced chemical equation. Magnesium carbonate plus sulfuric acid produces a salt, which is magnesium sulfate, plus water plus carbon dioxide gas. To balance it is balanced. So we are given the mass of magnesium carbonate, and we need the volume of carbon dioxide produced. We'll first find the moles of magnesium carbonate. That would be 100 upon the MR. MR will be 24 plus 12 plus 3 times 16, 84. This is equals to 1.19. Now in the equation, the ratio of magnesium carbonate to carbon dioxide is 1:1. So when 1.19 moles of magnesium carbonate are used, 1.19 moles of carbon dioxide are produced. To find the volume, we'll multiply the number of moles with 24. So the volume is coming 28.6 dm cube. The next question, calculate the number of magnesium ions and chloride ions in 50 grams of MgCl. For this, we'll write the ion equation first. MgCl2 has Mg2 plus ion and 2 chloride ions. Now the moles of magnesium chloride over here will be 50 upon the MR. MR is 24 plus 2 times 35.5. This is equals to 0.53. n is equals to 0.53. Now to find the number of magnesium 2 plus ions, since in the equation that we had made, which was the ratio of magnesium chloride to magnesium ions is 1:1. So the moles of magnesium ions will also be 0.53. Now to find the number of ions of magnesium, we'll multiply the number of moles with the Avogadro constant. This is coming equals to for chloride, the ratio of magnesium chloride to chloride ion is 1:2. So the number of moles of chloride will be twice the number of moles of magnesium chloride. So 2 times 0.53 into the Avogadro constant. So number of ions is equals to 6.4 into 10 to the power 23. The next question is calculate the moles of hydrogen ions in 20 centimeter cube of 0.1 molar sulfuric acid. The equation for this would be H2 H2SO4 ionizes to 2H plus SO4 2 minus. We are given with the concentration and the moles and the volume and the concentration of H2SO4. So with that we'll find the number of moles of sulfuric acid using the formula N is equals to C into V upon 1000. C over here is 0.1, and because the volume is in centimeter cube, so we will divide it by 1000. This will give us the number of moles, which is equals to 0.002. Now, as in the equation, it was given that H2SO4 was producing 2 moles of hydrogen ions. So the number of moles of hydrogen will be twice the number of moles of H2SO4. So we'll multiply this with 2. So 2 times 0.002 will give us the moles of hydrogen ion, which will be equals to 0.004. the next question is, how many molecules of methane gas are there in a volume of 10 centimeter cube? If the formula for volume is V equals to N into 24,000, because we have the volume in centimeter cube. Now to find the number of moles, we'll divide the volume by 24,000. So N equals to 10 upon 24,000. So now we've got N. Now to find the number of molecules, we'll multiply N with the Avogadro constant. So 1 upon 2400 into 6.02 into 10 to the power 23. So P equals to 2.5 into 10 to the power 20 molecules of methane gas. Now the next formula is for the percentage the next topic is percentage of element in a compound. The formula for this is the mass of the element in the compound upon the MR of the compound into 100. For example, the question is, calculate percentage of water in copper sulfate crystals. So in copper sulfate crystals, there are 5 moles of water. So the mass of water will be 5 times 2 plus 16. That is 90. Now we'll divide 90 by the total MR of this compound. The total MR will be 90 plus the MR of copper sulfate. Copper is 64, so 64 plus sulfur is 32 plus 4 times 16. 160. So divided by 160 plus 90 into 100. So the answer is coming 36%. Next is the mass of an element in a given mass of its compound. For this, the formula is AR of the element or mass of the element upon MR of the compound into given mass of the compound. The question says calculate the mass of oxygen in 50 gram of copper sulfate crystals. So for copper sulfate crystals, the formula is again CuSO4.5H2O. Now the AR of oxygen in this will be 4 plus. In this compound there are 4 oxygen over here and 5 oxygen over here, because 5 into 1 is 5. So the AR of oxygen will be 9 times 16, while the MR of the whole compound is 250 as we found in the last question. Now the given mass of the compound is 50 gram. So we'll multiply this by 50 and the answer will be 28.8 gram. So in 50 gram of copper sulfate crystals, there are 28.8 gram of oxygen atoms. Next is percentage purity. For this, the formula is pure upon impure into 100. The question is calculate the percentage purity when 100 gram of impure copper is electro refined and 20 gram of pure copper collects at the cathode. So the question says that there are 100, the impurity, the mass of the impurity is 100 gram, while the purity, the pure copper is 20 gram. So we'll put these values in the formula. 20 upon 100 into 100 equals to 20%. 20%, so 20% of the copper at the anode was pure. The next topic is percentage yield. The formula for percentage yield is experimental value theoretical value into 100. Now the experimental value is always given in the question, while the theoretical value you find from the given data. Calculate the percentage yield of calcium oxide when 20 gram of calcium carbonate is heated strongly to give 50 gram of calcium oxide. So in this question, 50 gram is the experimental value, while we'll have to find the theoretical value using, it's 200 gram over here. So we'll have to find the experimental value using this value of calcium carbonate that is given. So first we'll write the equation. Calcium carbonate on decomposing gives calcium oxide plus carbon dioxide gas. First we'll find the moles of calcium carbonate. For that we'll divide 200 by the MR. The MR will be 40 plus 12 plus 3 times 16. So the number of moles of calcium carbonate are 2. Now the ratio of calcium carbonate to calcium oxide is 1:1. So the number of moles of calcium oxide will also be 2. Now to find the theoretical value of calcium oxide, we'll multiply 2 with the MR of calcium oxide. The MR of calcium oxide is 40 plus 16, that is 56. This will give us the mass. So mass is equals to 112. Now this is the theoretical value. Experimental value is 50 grams. So now to find the percentage yield, we'll divide the experimental value by the theoretical value and multiply it with them. This is equals to 44.6%. This is the percentage. Another question for percentage yield. Calculate the next topic is percentage of element in a compound. The formula for this is the mass of the element in the compound upon the MR of the compound into 100. For example, the question is calculate percentage of water in copper sulfate crystals. So in copper sulfate crystals, there are 5 moles of water. So the mass of water will be 5 times 2 plus 16. That is 90. Now we'll divide 90 by the total MR of this compound. The total MR will be 90 plus the MR of copper sulfate. Copper is 64. So 64 plus sulfur is 32 plus 4 times 16. 160. So divided by 160 plus 90 into 100. So the answer is coming 36%. Next is the mass of an element in a given mass of its compound. For this, the formula is AR of the element or mass of the element upon MR of the compound into given mass of the compound. The question says calculate the mass of oxygen in 50 gram of copper sulfate crystals. So for copper sulfate crystals, the formula is again CuSO4.5H2O. Now the AR of oxygen in this will be 4 plus, in this compound there are 4 oxygen over here and 5 oxygen over here, plus 5 into 1 is 5. So the AR of oxygen will be 9 times 16, while the MR of the whole compound is 250 as we found in the last question. Now the given mass of the compound is 50 gram. So we'll multiply this by 50 and the answer will be 28.8 gram. So in 50 gram of copper sulfate crystals, there are 28.8 gram of oxygen atoms. Next is percentage purity. For this, the formula is pure upon impure into 100. The question is, calculate the percentage purity when 100 gram of impure copper is electro refined and 20 gram of pure copper collects at the cathode. So the question says that there are 100, the mass of the impurity is 100 gram, while the pure copper is 20 gram. So we'll put these values in the formula. 20 upon 100 into 100 equals to 20%. 20%. So 20% of the copper at the anode was pure. The next topic is percentage yield. The formula for percentage yield is experimental value upon theoretical value into 100. Now the experimental value is always given in the question, while the theoretical value is defined from the given data. Calculate the percentage yield of calcium oxide when 20 gram of calcium carbonate is heated strongly to give 50 gram of calcium oxide. So in this question, 50 gram is the experimental value, while we'll have to find the theoretical value using, it's 200 gram over here. So we'll have to find the experimental value using this value of calcium carbonate that is given. So first we'll write the equation. Calcium carbonate on decomposing gives calcium oxide plus carbon dioxide gas. First we'll find the moles of calcium carbonate. For that we'll divide 200 by the MR. The MR will be 40 plus 12 plus 3 times 16. So the number of moles of calcium carbonate are 2. Now the ratio of calcium carbonate to calcium oxide is 1:1. So the number of moles of calcium oxide will also be 2. Now to find the theoretical value of calcium oxide, we'll multiply 2 with the MR of calcium oxide. The MR of calcium oxide is 40 plus 16, that is 56. This will give us the mass. So mass is equals to 112. Now this is the theoretical value. Experimental value is 50 grams. So Now to find the percentage yield, we'll divide the experimental value by the theoretical value and multiply it with 100. This is equals to 44.6%. This is the percentage. Another question for percentage yield. Calculate percentage yield of calcium sulfate when 100 centimeter cube of 0.1 mole per decimeter cube of sulfuric acid reacts with calcium to give 0.5 gram of calcium sulfate. Now in this question, we have been given with the theoretical value, with the experimental value, which is 0.5, and we have to find the theoretical value. So for the theoretical value, we'll have to write the balance equation first. So calcium plus sulfuric acid produces calcium sulfate plus hydrogen gas. Now the moles of sulfuric acid we'll have to find using the formula N is equals to C into V upon 1000. C is 0.1, V is 100 upon 1000. So N is equals to 0.01. Now, when the ratio of sulfuric acid to calcium sulfate is 1:1, so 0.01 moles of calcium sulfate are produced. Now to find the mass of calcium sulfate, we'll multiply 0.01 by its MR. MR of calcium sulfate will be 40 for calcium plus 32 for sulfur and 4 times 16 for oxygen. So the mass is coming equals to 1.36. This is the theoretical value. Now to find the percentage yield, we'll divide the experimental value by the theoretical value. So 0.5 upon 1.36 into 100. This is equals to 36.8%. This is the percentage yield. Next topic is the empirical formula. The empirical formula is the simplest ratio between the elements of a compound. Now to find the empirical formula, we will first divide the given mass or percentage by the element's atomic mass. Divide mass or percentage by elements atomic mass, not molecular mass. Then we will identify the simplest ratio, and we'll divide all ratios by the simplest ratio. That is how we get the empirical formula. Now we'll do a question on this. First is the empirical formula of a compound containing 38.8% carbon, 16.2% hydrogen, and 45% nitrogen by mass. We'll make 3 columns, one for carbon, one for hydrogen, and one for nitrogen. So we have to divide the given percentage by the AR of the element. So 38.8 upon 12 equals to 3.23. 16.2 upon 1 equals to 16.2, and 45 upon 14 equals to 3.21. Now this is the simplest ratio, so we'll divide all ratios by the simplest ratio. 3.23 upon 3.21 equals to 1. 16.2 upon 3.21 equals to approximately 5, and then 3.21 upon 3.21 equals to 1. So we have got the ratio of the elements, that is 1:5:1. So the empirical formula will be CH5N. Now for molecular formula, first we find the empirical formula and then we calculate the empirical formula mass. Then we divide the given molecular mass by the empirical formula mass, and lastly we multiply the empirical formula by the answer by the multiple we found in the last part. That is, when we divided the given molecular mass by the empirical formula mass, we got a number, and we'll multiply that number with the empirical formula to get the molecular formula. So for this question, first we'll find the empirical formula. We'll make 3 columns: carbon, hydrogen, and oxygen. So dividing 40 by the AR of carbon, 3.32, dividing 6.72 by 1, so 6.72, and dividing 53.28 by 16, 3.33. Now this is the simplest ratio. I will divide all ratios by the simplest ratio. This is 1, 2, and so the empirical formula will be CH2O. Now for the molecular formula, we first have to find the empirical formula mass. Now for the empirical formula mass, we had the empirical formula CH2O. Now over here carbon is 12, as there are 2 hydrogens, so 2 times 1 is 2, and 16. This is equals to 30. Now in the question we were given that the molecular mass as 180. We'll divide the molecular mass by the empirical formula mass. 180 upon 30 equals to 6, and multiply this multiple with the empirical formula. So 6 into CH2O. This will give us C6H12O6. Because we have 1 over here, 6, 1 are 6, 6 2 are 12, and 6 1 is 6. So this is the molecular formula, and this is the empirical formula. Next is dilution. For dilution, we have the formula C1 into V1 equals to C2 into V2. This means these are the moles before dilution, and these are the moles after dilution. So taking the question, so here these are the data before dilution, and this is after dilution. Now C1 into V1 equals to C2 into V2. C1 is 2 into V1 is 100. We have to find C2, and V2 is 200. So this C2 will come as 1. Now the formula for neutralization reactions. C1V1 upon N1 equals to C2V2 upon N2. Over here, C1 and V1 are the concentration and volume of the acid, and N1 is the moles of the acid in the balanced chemical equation. Similarly, C2 and V2 are the concentration and volume of the alkali, and N2 is the number of moles of the alkali in the balanced chemical equation. So for example, calculate For this, we'll first write the balanced chemical equation. So H2SO4 plus NaOH produces sodium sulfate plus water. The balanced chemical, for balancing this, we multiply 2 over here and 2 over here. So we have the concentration of the acid as 1 into the volume of acid as 50. Now in the balanced chemical equation, the number of moles of acid are 1, so we'll write 1 here equals to, we have the concentration of the alkali as 2. We need to find the volume of the alkali, and the number of moles of the alkali in the balanced chemical equation are 2. So the volume of the alkali is coming equals to 50 centimeter cube. The last topic is the limiting reactant. In limiting reactant, we first find the ratio of, we first write the balanced chemical equation, and if the ratio of both the reactants is 1:1, then we'll use the moles of the reactant which is the limiting reactant, that is, which has less number of moles. But if the ratio comes 2:1, then we'll have to do more working to find the limiting reactant. So first we'll take a question, the 1:1 ratio. Now first we'll write the balanced chemical equation. NaCl plus silver nitrate produces sodium nitrate plus silver chloride. Here the ratio is 1:1. So first we'll find the moles of both the reactants. The moles of NaCl will be 5 upon its MR. MR of NaCl will be 23 plus 35.5. That is 58.5. This is equals to 0.085. The moles of AgNO3 will be 5 upon the MR of AgNO3. MR of AgNO3 will be 108 plus 14 plus 3 times 16. So 170. This is equals to 0.029. Now as we can see, the moles of AgNO3 are less in number. Therefore, AgNO3 will be the limiting reactant, whereas NaCl is in excess. Now what happens is that when the reaction occurs, all of AgNO3 is reacted while NaCl remains. So the number of moles of AgCl that we'll find will be using the moles of the limiting reactant because all of it will react. So the moles of AgCl produced will also be 0.029 because they're in the ratio 1:1. So now to find the mass of AgCl, we'll multiply 0.029 by the MR of AgCl to find its mass. The MR of AgCl will be 108 plus 35.5, 143.5. So the mass of AgCl will be 4.16 or 4.2 gram. Now we take another question with a 1:1 ratio. Again, we'll first write the balanced chemical equation. There is a reaction between barium carbonate and sulfuric acid. So this will produce a salt, that is barium sulfate, water, and carbon dioxide gas. Now, as we have a ratio of 1:1, we'll find the moles of both the reactants. For barium carbonate, 20 upon its MR. MR of barium carbonate will be 137 plus 12 plus 3 times 16, 197. This is equals to 0.102. For H2SO4, the number of moles will be 30 upon 2 plus 32 plus 4 times 16. This is equals to 0.306. Now here we can see again that the moles of BaCO3 are less than the moles of sulfuric acid. So barium carbonate is the limiting reactant and sulfuric acid is in excess. So we'll again use the moles of the limiting reactant. The ratio of barium carbonate to barium sulfate is 1:1. So the moles of barium sulfate will be 0.102. To find the mass of barium sulfate, we'll we'll multiply 0.102 by its MR. The MR of barium sulfate will be 233. So the mass is equals to 23.8 gram. Now we'll do a question of limiting reactant in which the ratio will be 2:1. Calculate the mass of Na2SO4 when 50 gram of NaOH reacts with 10 gram of H2SO4. So first we'll write the balanced chemical equation. The reaction is between sodium hydroxide and sulfuric acid. Producing sodium sulfate plus water. Here we can see that the ratio is 2:1. Now first we'll find the moles of both the reactants. For NaOH, the number of moles are 50 upon the MR, that is 23 plus 40. So the number of moles of sodium hydroxide are 1.25. For sulfuric acid, we'll divide 10 by the MR, which is 98. This is equals to 0.102. Now to find the limiting reactant, we'll use the ratio of NaOH to sulfuric acid 2:1. We'll write the number of moles of the reactant with the larger ratio, that is sodium hydroxide. So 1.25 moles of sodium hydroxide require X moles of sulfuric acid to be neutralized. So X is equals to 1.25 upon 2. X is equals to 0.625. So this means that to neutralize 1.25 moles of NaOH, we require 0.625 moles of H2SO4. However, we have only 0.102 moles of H2SO4. Therefore, H2SO4 is the limiting reactant. Once again, we require 0.625 moles of H2SO4 to neutralize 1.25 moles of NaOH. However, we have only 0.102 moles of H2SO4. Therefore, H2SO4 is the limiting reactant. So we'll use the moles of the limiting reactant. So the ratio of H2SO4 to N, so sodium sulfate is 1:1. So the moles of sodium sulfate would also be 0.102. We'll multiply it with the MR. The MR will be the mass of sodium sulfate will be equals to 13.5 grams. We'll do one more question with a ratio of 2:1. Calculate the mass of sodium carbonate when 20 grams of carbonic acid reacts with 20 grams of sodium hydroxide. Now the chemical equation will be NaOH plus H2CO3 produces sodium carbonate plus water. First, we'll find the moles of both the reactants. For NaOH, 20 divided by the MR. The MR is 40, so this is coming 0.5. For carbonic acid, 20 upon 62. This is equals to 0.32. Now we'll do the reporting to find the limiting reactant. NaOH is to H2CO3, 2:1, 0.5 is to X, so X is equals to 0.5 upon 2, that is 0.25. So to neutralize 0.5 moles of NaOH, we require 0.25 moles of H2CO3. However, the moles of H2CO3 that we have are 0.32. Therefore, we have more number of moles of carbonic acid than are required. Therefore, carbonic acid is in excess while sodium hydroxide is the limiting reactant. So now we'll be using the moles of sodium hydroxide to find the mass of sodium carbonate. The ratio of sodium hydroxide to sodium carbonate is 2:1. So 2:1. Now we have 0.5 moles of NaOH. So we will get 0.25 moles of Na2CO3. 0.25 into the MR of sodium carbonate, which will be 2 times 23 plus 106. So the mass of sodium carbonate that we get is 27. Ahmad.